says to sketch the function y equals minus x times x minus 2 squared times x plus 3 squared. Sketch the function and then verify with graphing software. We'll just sketch it and we can verify that later. To graph this, we need to first identify all the different things that we know. So it's useful to make a little list like this where we can go and calculate things real quick. Firstly, I want to know what is the degree of this function. So if I pick a pen to write with, we've got a single x there, degree 1. We've got 2 more x's there and 2 x's at the end. So our overall degree is degree 5. In addition, we've got positive x's there, and a single negative x. So our overall sign is going to be negative. Putting these two together, odd degree negative sign, we know that our end behavior will run from Q2 to Q4. We can also identify our x-intercepts fairly easily. Remember, to find x-intercepts, we want to make y equal to 0. So if we have a 0 on the left, which values of x will also give us zeros on the right side? Firstly, there's an x on its own. So if we let x equal 0, we'll get an overall 0 on the right. And there's a single one of those. So that is an x-intercept of 0 of order 1. Next, what would make this bracket equal to 0 would be a value of 2. So we have an x-intercept of 2. And because of this power of 2 up here, that tells us it's an x-intercept of order 2, which means when our graph gets to the value of 2, it's going to bounce on the x-axis. Lastly, we also have another x-intercept making this bracket equal to 0 of minus 3. And again, with this power of 2, we've got an x-intercept of negative 3 of order 2, which means another bounce. Our y-intercept, remember to find a y-intercept, we make all the x's 0. We can immediately see as soon as this x becomes 0, 0 times whatever these brackets end up being, the whole thing is going to end up being 0. So we have an x-intercept at 0. If I go and fill these points in, I've got an x-intercept at 0, which is also the y-intercept of 0. I've got an x-intercept at 2 of order 2, and an x-intercept at negative 3 of order 2. I can also go and plot my end behavior, which will run from Q2 down to Q4. And now I just fill in the rest. I know that as I come down to the x-intercept at negative 3, there's going to be a bounce. Next, when I get to the x-intercept of 0, order 1, I'm simply going to pass through. And then when I hit the x-intercept of positive 2 of order 2, there's going to be another bounce on the x-axis. And my graph ends up looking something like